Alright, so let's look at this question here, which is taken from the year 2017 CHIJ AMF SA1 paper 1. This question is on its additional mathematics application of differentiation. Okay, let's say I can do this proficiently. So we're given that PQR is an isosceles triangle with PQPR 50 cm. That's pretty okay. Shown in the diagram above, the QR is 28. So this is a rectangle here. Rectangle is being drawn. So show that AB, if AB is 2x, show that the area of the rectangle here, this shaded region here, is actually this expression here. Okay, great. I think the first thing is, of course, I'm just going to draw a perpendicular bisector downwards here. The problem with this rectangle here is we wouldn't know what is the height of the rectangle, right? So let's say this is the height that we're looking for. The thing is, we have to find the height in terms of x, right? So this is, we need to find the height here. So how do we find the height? I think what we could do is actually just make use of a similar triangle. So there's this triangle here, which is actually similar to this small triangle on top here. So that's what we need to do. I think wouldn't take long for us to figure out what is the total height of this isosceles triangle. So if we draw it out, this height here should be, this length here will be 14 cm. So the total height of the rectangle will be square root of 50 square minus 28 square, right? Just key in calculator. What we'll get is 50 square minus 28 square. There'll be, I'm not sure, there's a, okay, so 1716. 1716. I'll just leave it as 1716 first. Alright. So then after which what we could do is actually could find the total height, because this is x over here. Okay, we could let this be height instead. So I am going to just let this this be small h on top. Okay, so I can remove this because I know that the ratio of h over x is actually equals to this whole thing here over this 14 here. So it's this whole root divided by 14. Right. I key in wrongly the calculator. This should be 14 square. So we check the answer. 50 square minus 14 square. That's 48. Alright, that's it. So now we're gonna write that let HCM be the shortest distance of point P to B to DC. Okay, so this is H. Is it in cm? They're all in cm. Okay, great. So in this case here, the total height perpendicular height of triangle PQR is equals to square root of 50 square minus 14 square, which we got just now was 48 cm. Okay, so by similar triangle, by ratio, by properties of similar triangle, we know that h over x here is given by, or actually just h over the total height 48 is given by x over 14. So h over 48 is x over 14. Okay, great. Okay, so I know that the total height here will be 48 x over 14, small h. This case will get us 40 over 14, 24 over 7 x. Okay, great. Now once we have a small h, we know that the length of the dA, so hence dA will be 48 minus h, right? So this height here is 48 minus h, because this whole length here is 48 minus of h will be 48 minus h. So the area A will be x multiplied by 48 minus h. H is actually 24 over 7, so x. There you go. So we need to make this a subject. Need to factorize the 24 out. So we need to factorize the 24 out, 24 over 7 out, because there's a negative 1 here. So this case here we'll get is just divide. So it's 24 over 7x 14 minus x. There you go. This will be 24x 14 minus x over 7 cm square. There you go. So that's our area A there. So I think the general idea is essentially finding the two variables. So in this case is h and x, and try to relate them before you start solving. All right. So let's obtain the expression of dA dx. I think this should be quite quick. Let's look at that part 2. So if A is equals to 48x, I'm going to just put this as 48 over 7 x 14 minus x. Could I just expand this in? 40 over 7, this is 14x. I think this is easier. I don't want to use product rule. dA dx will just be 48 over 7. This is a constant, leave it outside. There you go. So could factorize the 2 out if you want to. Or we could just expand it in. So this will be 96 minus of 48 over 7 multiplied by 2. That will be 96 over 7x. After which we need to, given that x can vary, find the value of x for which the area rectangle is stationary. So at stationary point, at stationary value, dA dx is equals to 0. So 96 minus 96 over 7x is equals to 0. Then 96 equals to 96 over 7x. This would get the 7 equals to x equals to 7 cm. Right. So given that x can vary, so x would be 7 when it's stationary value. Then after which, last part, explain why this value gives the largest area possible. We could use second derivative test. So we use second derivative test. So for part 4, since d square a dx square is equal by negative 96 over 7, which is less than 0. Hence, x equals to 7 gives maximum value of a. Okay, so that's how you do this question here proficiently. If you have any questions or comments, please do let us know, and I'll see you in the next question.